Okay, last section in the chapter. Really important section. It's all about the sun. The sun is obviously really important to life on Earth. Most life, almost all life on Earth needs the sun, and if it did not, if we did not, we essentially would not have life on our planet. So what is the sun? It's a star. So when you look up in the sky at nighttime and you see stars, that's what you're seeing. The sun is a star. Really, all what a star is a giant hot ball of gas held together by gravity. Doesn't sound very exciting, but that's what it is. And we're going to talk in a little bit here about what specifically it is inside there, but that's what a star is. A really giant hot ball of gas held together by gravity. Now, our sun, I hate to burst your bubble, is pretty average. We got an average star in our solar system, but that's not a bad thing. The fact that it's average is good for us here on Earth. So the sun is medium sized. So there is stars in our universe that are smaller. There's stars that are bigger. We are average. So it's a medium sized star compared with other stars in the universe. And we think it's about 4.6 billion years old. So we think that's how old our solar system is. Obviously, the sun formed in the middle of that, in the center of that, about 4.6 billion years ago. Looking at the size of it, it's so hard to just even mentally get an idea of how big it is. But if you look here on the inset, just showing you a little bit of relation, obviously that's not a real picture. We're not going to get that because Jupiter is not between us and the sun, but giving a little size relation there, Jupiter being the largest planet in the solar system, just even look at that size there, and then now look at Earth. Look at how small Earth is in comparison to actually the size of the sun. So the diameter of the sun is about 109 times the diameter of the Earth. So the sun is massive. So like I said, our sun is an average star. On the picture here, it shows you some of the different types of stars that we have in the universe. They get their names based on their size and their color. Now, just like on Earth here, how color indicates temperature to us, the same thing happens in space. Why would it be any different? So think about things on Earth that are hot, but not crazy hot. So think of like a candle, think of a campfire. They start to take on that orange reddish glow versus things on Earth here that are really hot. So think of like a welder's torch. They have a blue color to them. So stars that have a blue color are hotter than the stars that have an orange or a red color to them. So our star is actually, if you look on the picture there, what is called a yellow dwarf star. All right, so what's happening in the sun? This is what's happening, nuclear fusion. So nuclear fusion is a process by which hydrogen fuses together to form the element helium. I'll say that again. Hydrogen fuses together to form helium. Now, that is not something that is common. That is not something even for us here on Earth to get that to exist is really, really challenging to happen. But the sun has hot enough temperatures to make that happen. Now, when that happens, a great deal of energy is released. Even their little arrow they have on here, the orange thing, I don't think it's big enough. There is a massive amount of energy released in that process, and that is essentially the energy that we are getting from the sun. So nuclear fusion, hydrogen fusing into helium, is happening in the sun's core. So in the middle of the sun, this is happening, and in that process, a great deal of energy and heat is released in that process. Huge amounts of energy given off. Now the sun has layers just like we have layers, and we're not going to get into all of these. I mentioned corona in the last atmosphere, so that is the outermost layer. We can only see it during a total eclipse, and you'll start to see what happens. The temperature, so the temperature actually also increases as we go in. We have the photosphere, which is the visible surface of the sun. Photo meaning light, it's what we see. Then there's the chromosphere, convective zone, radiative zone, and then finally the core where that nuclear fusion is occurring at. The corona is the outermost layer of the sun's atmosphere, extending millions of kilometers beyond the sun. You'll notice on that picture that I showed you earlier here, and you see on this one too as well, we have these dark areas on the surface of the sun. Now the sun has a magnetic field, just like the Earth has a magnetic field. And in the video you guys are watching today, it's going to talk about that. So that magnetic field actually creates cooler areas on the surface of the sun, and those cooler areas are darker. So sunspots are areas of gas that are cooler than the gases around them. They're caused by the sun's magnetic field. Now sunspots go through trends on the sun's surface. So they have times when they peak, and then they have times when there are less. Fun fact, Galileo actually went blind studying sunspots. He discovered them and he noticed there's patterns in them. But like we said earlier, you can't stare at the sun because it's going to cause you to be blind. And that did actually happen to Galileo. A couple other features your book talks about. Sometimes loops of gas called prominences or solar flares can be seen jumping from the surface of the sun, or groups of sunspots. Think about all of this material that's getting ejected into space. And what it does is causes increased solar radiation energy coming from the sun to Earth. So when this happens, things can happen on Earth. So they can add additional high energy to our atmosphere, causing electromagnetic disturbances on Earth, so that it can interfere with things like satellite disruption and other things happening here. So think about that. Something just as simple as that on the sun can actually drastically affect life on Earth here. Another thing that happens are these gorgeous, cool things that happen here. The sun produces solar wind, which is electrically charged mixtures of protons and electrons, and that's on a normal basis. But during those times that I just showed you, like when we have solar flares or solar prominences, they become increased. So we have an increase in solar wind. And what can be created from that are these things called auroras. Colorful light shows in the sky cause when these particles from the solar wind interact with gases in our atmosphere. It charges them, it causes them to be ionized, and this is going to be in your video today too. It's going to show you about it. The places that we see it most evidently, and you're going to see why in the video that is, because of our Earth's magnetosphere, is more obvious in the northern pole and then the southern pole locations. If they happen in the northern locations, we call those aurora borealis, and so that's what we see up here in northern Minnesota. Whereas if you were in the southern part of Earth, those are called aurora australis, or the southern lights. So these are not happening because of light being reflected off of glaciers. That used to be a common misnomer. This is because an increase in solar wind is charging particles in Earth's atmosphere, causing them to release photons of light, giving us these beautiful patterns. Now, these things happen when we have increases in solar wind, and we know when that happens. So the cool thing is if you've ever paid attention to the weather at nighttime, they will actually say we're going to have an increase in auroras tonight, so you can pay attention to that. There is some websites too, really cool places that will say, hey, you know, tonight's a good night, so you're not spending your entire life outside waiting for these things to happen. But clearly a beautiful feature that we get from the sun interacting with Earth's atmosphere. All right.